Hi, welcome to the Shiko Math Lab differential equation problem solving session. So today we will take a look at this differential equation and how do we solve it. And this one, we have a square root of the y involved here. All right, okay, let's go ahead and getting started. And let's take a look at how we do this. Okay, so for when we try to do this problem, it will be similar like we did before. So the tool we're going to use is use the Bernoulli equation again. So let me just try to write it down here to serve as um, memory. So when we kind of the reference, so when we try to solve the problem, we can do that. Okay, so this one's here, the Bernoulli will be, so if you remember, will be that the y prime will be plus, then here is the t. So let's use the t, a function of the t, pt, and the y will be equal to the function of the qt and the y that ends out here. All right, so for this one, in order to match the Bernoulli equation, the first things we want to do is let's try to divide by, the divided t, both sides here. Okay, so then this end will be y prime minus 2t and the square root of the y. And then here, this will be the 40. Okay, so then this will be the 4 over t and the y. Okay, so for the Bernoulli here, this is a y and this is y to nth power. So we can move it. So let's try to do here. So we move the y to this end. So we will say this is y prime. Then minus 4 over t, the y, then move the others over, so this one's here, so this is 2t. Then the square root of the y, we can change y to what? Y to the 1/2 here. Okay, so now we will see here. Okay, so here, if you compare to the Bernoulli equation, so we will see this one, see here, this is my n is equal to 1/2, and this is my pt, right? And this is my qt, see here. Okay, so because this is the Bernoulli, so let's applying the approach. So what do we need to do? The step number one, right? Just like we did before. The step number one, we need to define the new variable v. So v is like always is y, the 1 minus n. So this will be y, the 1 minus 1/2. So it will be y equal to the 1/2, or you can put the square root of the y here. Okay, and then step number two, what do we need to do? We need to replace the dy dt to the dv dt, right? So step number two. So the v is here. So let's take a look at the dv dt. All right, so here this will just be the 1/2. Use the power rule. And the y to the negative 1/2 is 1/2, so it will be the square root of the y. Okay, and then because y is a function of the t, so we have dy dt here. So remember the step number two is replace the dy dt. So I want to solve for the dy dt. Right? So basically you just times 2 and times the square root of the y to the other side. So dy dt will just be the 2 times y, the square roots, right? So you just change this one be 1, the dv dt. Right, or you can just say this is a 2y, the 1/2 dv dt. Okay, so the step number three is to replace the replace your original function, the dy, the dy dt, change it to a dv dt here. So here, this is let me try to color that so we know what is okay, so this is my original functions, right? So y prime is here. So now I replace with the dy, replace the dy dt with dv dt. So this one I will replace is a 2y half dv dt, right? So minus 2t. Okay, so minus so minus 1 4t's, right? So 4 over t, and the y is equal to the 2t, the y half. All right, so here just make sure. So this is original. Now we change this to the Bernoulli equations, right? So we plug that in. All right. So now, what what is the step number 4? See here, the step number 4 is I want to okay. So I want to simplify this differential equation and without the dvdt by itself. So what I can do here, so what I need to do is divide by 2 the y half, and then this is 2 the y half here, right? So this is step number 4 we want to do. Now after that, what do we have here? So in here, these 2 cancel, so let's see here. Let me put this step number 4 a little bit down here. So, okay, so the first one is 2y half, 2y half. So I only have dv dt left. Okay, then the second part here, this is 4t and the y. So 4 and 2 become 2, right? And then the t still there. And this is y and the y half, right? So what do we have? So it's y half here. All right, and then in here the 2t, 2 and the 2 cancel, so and the y half cancel, so this cancel, so I only have a t. Then the last steps here, because I know my v's here, okay, so my v's here, v is equal to the square root of the y's here, right? Okay, so now I can say here, so this equation, I can change it to a dv dt minus 2t, all right? And the square root of the y's here is the v's, right? So I change this to the v's here, and this is the t. Okay, so that's good. So this is my standard, the one order, the the linear forms here. Okay, so now the next thing is here, step number 5. Let's try to find the integration factor. Okay, so here so this is my new PTs, right? Okay, so just like we did before, so what we do here, we find the du dt will be equal to the negative 2t, 2 over t, and the u. Now when we're solving for u's here, so we can do here, we can just say the du, move the u to here, so this is u, this is negative 2, here, right? So we can say negative 2, then for the move dt over there, and here is the t here. Okay, after this one's here, now what I can do, I can say, okay, I want to integrate both sides. So let's integrate both sides. So after I integrate both sides here, I will have the natural log u is equal to the natural log. So this is the two t's, right? So I will have the this is the natural log. So I have -2 the natural log t's here, and because the natural log property, this 2 I can move to natural log t to the -2. So this is a natural log 1 over t squared. Okay, so now I can set u, I can cancel out, so I will say the u will be equal to 1 over t squared. Okay, so this is my integration factor. Now, so what is step number 6 here? I need to put the integration factor, multiply the integration factor to the previous the equations here. So I will need to do is I will multiply the ut squared to this equations, right? Both sides. I multiply the right hand side and the left hand side here. Okay, let's take a look at what we have here. So then you multiply here. So this will be 1 over t squared dv dt. Then minus 2t cubed, right, v. Then this one here will be 1 over t. As we see from the previous, what happened to these terms here, right? So for these terms here, it just become, but here, this just become the dt, and this is v over t squared, right? So if you do the the v over t squared, and this one will be equal to what? This is equal to 1 over t here. So if you do the product rule, so the holding the one part 1 over t squared dv dt, then minus you hold the v, then the t, the 1 over t squared derivative will be -2t's, right? All right, so here, now the step number 7 is what you integrate the both sides. So when you integrate the both sides here, okay, so here now we do this again. All right, so just like we did before. So here we will integrate both sides here. Okay, so when you integrate both sides, then what happens here? The left hand side, because this is the v. I should okay, so the left hand side here, so it's the derivative of vt squared. So you integrate will just become v and t squared, right? Then the right hand side will be the natural log t plus c. Okay, so plus c is here. All right, now you times t squared both sides, so you will get v is equal to the t squared natural log t plus, okay, so it's t squared natural log t plus t squared. I should have said this is integrated by t squared times c here. Then the v is equal to, okay, so v is equal to the square root of the y's, right? So I replace it. Then I say the square root of the y is equal to the t squared natural log t plus ct square. Okay, so my initial conditions here. So let me write down my initial condition. My initial conditions here is y1 equal to 4. All right, that means y equal to 4 when t equal to 1. Okay, y equal to 4. So in here, the y equal to 4, right? So this number equal to 4 when t equal to 1. So what I have here, so I will have 2 is equal to 1 times natural log 1 plus c here. Natural log 1 is 0. So what I see here, c equal to 2. All right, so good. So now I finally solve in my equations. So I know the square roots of the y will be equal to, so the square roots of the y will be equal to the t squared natural log t, all right, plus, right, t squared, the t squared, so 2, right? So it's 2 the t squared. Okay, so t squared natural log t plus 2t squared. All right, then finally, if you want, you can just y is equal to t squared natural log t plus 2t squared squared. Okay, that's it. That is our solution. And so as you can see, when we apply the Bernoulli equation is always the same steps here. Now, I hope this help. All right, guess I will talk to you in our next videos. All right, okay. So bye and have a good day.